My name's Jamie Wilson. I'm a postdoc in the Maths and Stats department at the University of Limerick, Ireland. And as a public service fellow with Research Ireland, I've been working with the Food Safety Authority on developing their risk ranking model for chemical contaminants in food. So I'm just going to give a brief overview of what I'm going to talk about today. So first of all, I'll just give some motivation. So why do we want a risk ranking model? Then I'll discuss some of the individual components of the model, and then the updates that we've been making to the model, and then lastly, the next steps for the project. So why do we want a risk ranking model? So the Food Safety Authority has national responsibility for the coordination and enforcement of food safety legislation. And part of enforcement is in sampling products on the Irish market. So each year the FSAI develops a national chemical sampling plan, and there's a number of factors that feed into that, such as current legislation, risk, non-compliance rate, and so on. But there's such a huge range of food and chemical combinations that they've recognized the need to establish a formalized approach to risk ranking in order to effectively use their resources and to focus on the areas that are of greatest concern to consumers. So a scientific committee was established in order to develop the initial model and to conduct a pilot study. So I'm just going to give, on this screen here, I'm just showing a schematic overview of how the model works, but I'm really just drawing your attention to the fact that it's based on three main components. So we have an exposure score, where this is, how much someone will be exposed to a substance from a particular food. A toxicity score, which is what is the severity of the substance, and then a policy score, which is essentially, is there any legislation already in place for this substance? And then the final score will be a specific combination of those scores. So it's essentially a scoring system. Mainly, I've been working on the exposure component just because that's where we have some room to do some modeling. The toxicity score and the policy score, for the most part, they're determined by expert opinion, although there's still a little bit of work in integrating those into the model. So I'm just going to describe the different components. I'm not going to go into a huge amount of detail. For the exposure score, it's essentially the sum of two terms that you can see at the top. For the first term, we start with a health-based guidance value. So this can be an established acceptable daily intake or tolerable daily intake, or it might be based on a benchmark dose with an appropriate safety factor applied. But the first term will be the mean exposure from a food of interest as a percentage of the health-based guidance value. And then we just score that according to the system on the right there, which is just based on increments. So in this example, for food A, it already contributes 55% to the health-based guidance value, so it would get a score of 30. And for the second term, it works pretty much the same way, except it's the mean exposure for all foods. So in this case, that actually exceeds the value, so it would get the maximum score of 60. And then the final score is just the sum of the two terms. So in this case, it would be 90. Just to give you a concrete example, so this is from the pilot study where we're looking at acrylamide in crisps. So here, the contribution from the food itself was already pretty high. So it gets assigned a high score of 60. And then, of course, for all foods, it's also very high. So it also gets a score of 60. So in this case, we get the maximum score, which is 120. For the toxicity score, I mentioned this is mainly, it depends on expert judgment. So again, there's two terms. We have the critical effect that's identified from experimental studies. And then the other term is essentially the magnitude of the health-based guidance value. So it's essentially a scoring matrix where the potential hazard increases as you move from the top left to the bottom right. And if we look at our acrylamide example again, and we take the identified critical effect and the health-based guidance value, and we just sum those two terms. So in this case, we would get 80 for the toxicity score. For the policy flag, so I've basically covered this already. This is when you might have a maximum limit or a recommendation already in place for the substance, in which case you're just adding a small decimal amount to the overall score. So just to show you how the final score is calculated, so for acrylamide in this example, we take the product of the exposure score and the toxicity score, and then we add the policy flag and we get the total score. So here I'm showing the results from the pilot study. This was quite limited in certain ways. So it was limited in, it was only a small number of substances that were included, and also the food groups were quite broad. So it's not overly helpful in terms of the chemical sampling plan. So the idea is to expand this to all the substances that we have occurrence data for, and all the foods that we have consumption data for. So just to give you, just to mention some of the updates that we're currently making to the model. The first is really just to do with harmonizing the data. So as you probably know, when it comes to exposure, we basically have two sources of information. We have the chemical concentration data, and then we have the food consumption data. And so the first issue is really just in making those two data sets compatible. For this, we're using Food-X2, and you're probably very familiar with this, but it's essentially a classification system where we have this large nested structure, and we have different levels of detail, and where the food groups belong to larger food groups at a higher level. And another issue then that we have with that is that the consumption data doesn't always match up with the concentration data very well. And so what we've done is we've just included multiple matching strategies in the model. So in the simplest case, you might just want to match a specific level. So you might want to focus just on a specific level of detail, or you might want to roll the different food groups up to a specific level. Or another way you can do it is with level up matching, so similar to other exposure estimation approaches. And so all of those options are being built into the model at the moment. The next update then is just the exposure estimation. So rather than doing point estimates based on averages, here we're using Monte Carlo simulations. So the basic idea is we don't know what the true exposure distribution is. So instead we sample. So we take a sample from the chemical concentration data, and we take a sample from the consumption data, and by combining those, we then get a sample from the exposure distribution, and then we just do that many times. So say 1,000,000 times, and that just lets us build up a picture of the exposure distribution. So we're explicitly including the variability that's in the data here. And another nice thing we can do from this is to aggregate by the Food-X2 level or the food groups. So we have the distributions and we can essentially propagate these up through the levels and then aggregate by the different groups. And this is very nice for the chemical sampling plan because it also has a sort of nested structure, and the different foods of interest can come from any level of the hierarchy. A couple of other things I just want to mention, I've put them here, but they're really a work in progress, and that's accounting for food processing using the raw primary commodities model. So this is accounting for changes in the yields due to food processing. And then also we're working on incorporating the Open Food Talks database in order to extract the health-based guidance values automatically. So just to show you, this is a very early example of what a dashboard might look like. So once we do the Monte Carlo sampling, we get two things. We get the overall exposure distribution, which you can see here on the left. This is for acrylamide. But you also get a distribution for each of the individual foods. So that's what I'm showing on the right there. That's just the mean of all those distributions. So you get an overall distribution, and you can see what foods contribute to the exposure. We also have a few drop-down boxes here. So as I mentioned, you can actually go in and select the Food-X2 level and view the exposure there. And even within a level, you can select a group and view the exposure there as well and see what contributes to that group. So it's just a nice way to explore the exposure and just to visualize things. So visualization is nice, but ultimately we want to use this for the chemical sampling plan. So we need to put this in a form that's going to work with that. So this is an example of the output for acrylamide, where on the left you see that everything's in this nested structure. Then we have the output, the individual outputs from the different components of the model, and then finally the risk ranking score. And in this form, it should be easy to merge this with the chemical sampling plan. So just to quickly mention what the next steps are for the project. So I've already mentioned incorporating the Open Food Talks database and the food processing factors. We still need to include the policy flags in an automated way. In terms of modeling, we still need to do a bit of validation. So we have compared our results with commercial exposure estimation software, and we do get very similar results, but we really need to do this more formally. There's a few other approaches that we might take, like Markov chain Monte Carlo, or we might just do maximum likelihood. I mentioned earlier towards the start that the scoring is just based on increments, but we might want to look into some non-linear methods for doing that in order to differentiate between high exposures and very high exposures. And then there's just ongoing dashboard development, and finally merging with the National Chemical Sampling Plan. And that's everything from me. So thank you very much.